I was standing near a terminal recently watching an old-school diesel feeder pull into the dock. You don't just see those ships, you feel them. The air turns thick with the sulfurous tang of heavy fuel oil, and the vibration from the massive reciprocating engine is so deep it feels like it's rattling your actual bones. It's loud, it's visceral, and it feels like the peak of 20th century industrial might. But then I saw something that felt like a glitch in the matrix. A 10,000-ton container ship, a towering wall of steel gliding toward the pier in total eerie silence. No black plumes of smoke, no bone-shaking roar, just the faint rhythmic sound of water parting against the hull. I pointed it out to a logistics coordinator standing nearby, expecting him to be impressed by the green technology. He didn't even look up from his clipboard. He just muttered, "It's not a ship, it's a giant power tool." When I asked how they plan to charge a beast that size without waiting for days, he pointed to a crane. I watched as it reached down, plucked a massive shipping container-sized block out of the vessel's spine, and slotted a fresh one back in. It looked exactly like someone changing the AA batteries in a TV remote, except the remote was a 740 TEU megastructure. What struck me in that moment wasn't the environmental impact, that's just the marketing layer. It was the realization that while we in the West are consumed by digital abstractions, debating character limits and virtual identities, a different kind of power is being quietly consolidated in the physical realm. This silent giant isn't just a vessel, it's a high-throughput, electrified manifesto. It represents a civilization that has moved past the thermodynamic limits of the diesel age and into a new era of hard-tech hegemony. It's a shift that's happening one silent kilowatt-hour at a time, and it suggests that the diesel endgame isn't a theory, it's already docked.
That is such a powerful image to start with. It really is. That contrast, that bone-shaking roar versus the eerie silence.
Eerie is the only word for it. It was almost unsettling.
It feels like something out of science fiction. But like you said, it's not. It's happening right now. And I think what's so important about your observation, your visceral reaction, is that the silence isn't just an absence of something. It's not just no noise.
Right. It's the presence of something else entirely.
Exactly. It's the presence of a fundamentally different operating system for how we move things. We're really talking about a civilizational shift here from, burning dinosaurs for the last 100+ years.
Which is all about combustion, explosions, heat, chemistry.
All chemistry. Yeah. And we're shifting to managing electrons. It's a move from chemistry to physics, and that changes everything.
We are not here to talk about a green press release or something.
And we've got the material to do it. We've got a whole stack here. Shipbuilding reports, some dense economic papers, actual battery logs, technical specs from the shipyards themselves.
And our mission today is to really understand how the physical realm, the actual, atoms and goods being moved around the planet, is being reconquered. While so much of the conversation in the West is focused on the digital, the app layer, the software.
The abstractions.
The abstractions, exactly. Someone is rewriting the global operating system for physical logistics, and most of us aren't even watching.
Which is why this matters. It matters to you, the listener, because while we're all busy debating app interfaces, the very foundation of how goods get to you is being re-engineered.
Yeah.
This is about who controls the flow of everything in this century.
So let's start with the machine itself. Let's talk about this ocean blue pufferfish, which I have to say is a fantastic name.
It is a great name. Heaton Wyland 01.
Ocean blue pufferfish #1. It sounds almost cute, disarming. But then you look at the specs from the Woohoo shipyard documents, and this thing is an absolute monster.
The name might be whimsical, but the engineering behind it is pure pragmatism. You use that analogy of changing AA batteries in a remote war. That is literally the operating principle here.
But the scale is just mind-bending.
Completely. The ship pulls into the dock. A specialized portside crane, which is itself a piece of precision engineering, reaches down into the spine of the vessel, and it removes the battery block. Here, this is not the battery pack from your car.
No, the manifests call them Containerized Energy Storage Systems.
Right. And what that means is a block that weighs roughly 4 tons.
4 tons per block.
With a capacity of around 430 kilowatt hours. Now, to give you some context on that, a typical American home might use, 30 kilowatt hours in a day?
So one of these blocks could power my house for 2 weeks.
And the ship doesn't just have one, it has a whole pack of them. The crane lifts the depleted one out, moves it to a charging bay on the dock, and slots a fresh, fully charged one right back in.
And this is the part that just floored me when I read it. The sources are saying the entire swap for one of these 4-ton blocks takes about 5 minutes.
5 minutes per battery.
Yeah.
Now, think about the alternatives. The old way, the diesel way, is called bunkering.
Right, where they pump in the heavy fuel oil.
Exactly. You're dealing with massive hoses, high-pressure pumps. You're checking for spills, monitoring flow rates. That whole process can take hours, many hours.
Or the other obvious alternative, which is just plug it in, like a giant electric car.
And if you did that with a battery of this magnitude, you'd be sitting at the dock for half a day, maybe longer. It completely destroys the economics of the vessel.
Which really gets to the core question I had when I was going through this. Why?
Yeah.
Why not just plug it in? I mean, we plug in everything else. Why go through this unbelievably complex engineering challenge of building these giant precision cranes, these standardized locking mechanisms, just to swap a box? Why not just get a really, really thick extension cord?
And that question gets you right to the heart of the hard tech logic. It's where I think a lot of Western analysis of this transition misses the point. The folks at Alt New Energy are one of the key players here. They lay this out perfectly. The first problem is grid impact. Imagine you have a 10,000-ton vessel, which is essentially a floating battery the size of a city block, and you plug it into the local harbor's electrical grid.
Okay.
You're asking for a sudden, massive surge of power, megawatts of it, instantly.
It's like trying to run a particle accelerator on a power strip from your garage.
The demand surge would be catastrophic. It would crash the local grid. You'd cause brownouts, blackouts for the entire port district, maybe the city next to it. To handle that kind of load, you'd need to build massive, dedicated substations that cost millions and millions of dollars per berth.
So the infrastructure just isn't there for direct fast charging at this scale?
It's not. But with swapping, the entire logic flips. Those depleted battery containers that are sitting on the dock, they can be charged slowly. They can be charged over a full 24-hour cycle.
So you're spreading the load over time.
You're spreading the load. You can charge them at 2 in the morning when industrial demand is low and electricity from, say, wind power is abundant and cheap. The swap station itself becomes a giant energy buffer for the grid.
So it actually stabilizes the local power supply instead of threatening to crash it.
The term they use for it is V2S2G, vehicle to station to grid. The station is a huge battery that helps manage the grid. It's an asset, not a liability. But that's only the first reason. The second one is pure economics. It's about asset utilization. Okay, a container ship is an enormously expensive piece of capital equipment. It costs a fortune to build. That asset only makes money for its owner when it's on the move, when it's sailing.
When it's moving water, as they say.
Right. If that ship is tied to a dock for 10 or 12 hours just to charge its batteries, that is what the operators call dead money. It's an asset that is depreciating, costing you money in crew and port fees, but generating zero revenue.
There was a phrase in one of the reports that stuck with me. Circulation without cease.
Oh, swapping enables that. You dock, you swap the batteries in the same time it takes to unload a few containers, and you go. It's the difference between a pit stop in a Formula One race and parking your family car overnight to charge.
A pit stop?
Yeah. In a high-volume, low-margin logistics network, that uptime, that constant circulation is the difference between profitability and bankruptcy.
And it's not just about the ships. That's another thing that jumped out at me from the technical standards. This is bigger than just maritime.
Detail. The battery containers are designed to be modular and interoperable. The standards mandate it, so the same block that powers the ship
Can be dropped onto the chassis of a heavy-duty truck.
or used to power the massive gantry cranes at the port, or the heavy forklifts moving containers. Or they can simply sit in a rack and function as an emergency power backup for the entire port facility during a blackout.
So they're not just building a battery for a boat.
No, they are building a standardized energy brick, a universal modular power source for the entire logistics chain. From ship to shore to truck, it's a holistic energy network.
That idea of standardization, it's the perfect way to zoom out a little. Because you can't have a universal standard like that by accident. It doesn't just emerge from the market. Someone, somewhere, has to have the power to say, this is the standard. Everyone will use this.
Which is exactly what's happening.
I want to talk about a man named Lao Chen.
Okay, let's hear about Lao Chen.
This comes from a really detailed account, a sort of day-in-the-life piece about a crane operator at the Ningbo Zhoushan port, which is one of the busiest ports on the planet.
Right.
Lao Chen has been working there for 30 years. I want you to just picture his workplace. For 3 decades, he sits in a small cab, suspended hundreds of feet in the air above the concrete, and his entire sensory world, his entire career, has been defined by noise and vibration.
The rumble of the diesel engines.
Constantly. The roar of the diesel trucks idling below, the deep guttural thrum of the massive generators on the ships, the constant vibration rattling his thermos of tea against the metal ledge of his window. He said he used to measure the passage of time by the sound of failing pistons and grinding gears.
That's a very industrial, very visceral way to experience time.
The smell of diesel fumes, of unburnt hydrocarbons, that was just the smell of work for him. It's a world of brute force. But then he watches this new system get installed. He sees the first of these electric vessels glide in, and his description of the battery swap is what's so fascinating. He called it surgical.
Surgical, that's not a word you associate with a container port.
Well, he said the crane, the swapping mechanism, moved with a quiet precision that was, in his words, unnerving. The massive locking pins engaged with the dull thud, a pneumatic hiss instead of the crash and grind of metal on metal. He said it felt less like a dirty, noisy port and more like a high-speed data center.
Wow. That is a profound shift in perspective for a guy who's been doing that job for 30 years.
It's a complete paradigm shift. And he had this key insight. He realized that for this whole ballet to work for the battery from the ship to fit perfectly onto the truck, for the crane's automated system to know the exact coordinates to grab, there had to be a master plan.
Lao Chen's observation from his crane cab is a perfect window into this concept of state capacity.
Exactly. When we unpack what he saw and we use the analysis from the CSIS and Alton papers, you see the stark difference in strategic thinking between East and West. What China is doing is driving this power battery standardization from the very top down.
It's a mandate.
It's a mandate. Yeah. The report mentions a target of 16,000 swap stations. That number just sounds astronomical. It sounds like a propaganda figure. Is that even remotely realistic? Because, you know, in the West, we announce ambitious infrastructure targets all the time, and then we miss them by a decade and billions of dollars.
It was a huge number.
Right.
But if you look at the documented deployment rates for other infrastructure, like high-speed rail or 5G towers in their system, it becomes credible. And the reason why it's credible gets back to that term, state capacity. In the West, our model is market fragmentation.
Right. Look at EV chargers for cars.
Example, for years we had the Tesla plug, the CCS plug, Shiademo in some places, different voltages, different power levels, a dozen different apps on your phone to pay. It's a chaotic mess for the consumer because we let the market fight it out.
It's the modern version of beta versus VHS, but for the fundamental infrastructure of your economy.
In the model that Lao Chen is observing from his crane, the state steps in and mandates a single unified standard. They say, this is the block, this is the voltage, this is the connector. And what that does is it dramatically lowers the barrier to entry and R&D costs for everyone else in the ecosystem. If you're a shipbuilder, you no longer have to spend $1 billion inventing your own proprietary battery system. You just design a hull that has a standardized slot to fit the block. If you're a truck manufacturer, same thing. You build a chassis that accepts the block. The state solves the most complex part of the puzzle for everyone.
So it solves the classic chicken and egg problem.
Yes. The report on electrifying medium and heavy-duty vehicles talks about this constantly. It's the biggest hurdle. Who is going to buy a multi-million-dollar electric ship if there are no battery swap stations? And who is going to spend $1 billion building swap stations if there are no electric ships to use them?
It's a stalemate.
It's a market failure. China's approach is to solve this by building the egg, the entire network of stations, before the chickens, the vehicles, have even fully arrived on the scene. It's a brute force solution to the adoption curve. They are, in effect, building the market into existence.
They are terraforming the industrial landscape.
And this approach contrasts so sharply with what another one of our sources calls Western vetocracy.
Vetocracy, I've heard this term before. It's the idea that it's easier to stop things than to build things.
It doesn't mean it's anti-democratic. It refers to a political system where no single entity has the power to say yes and get something built, but many, many different entities at the federal, state, and local level all have the power to say no.
Oh, I recognize this immediately. You want to upgrade a port in Los Angeles or New Jersey. Okay. First, there's the federal environmental impact statement, which can take 5 years. Then you have the state environmental agency. Then the local city zoning committee. Then the county planning board. Then the Historical Preservation Society might have an opinion.
Don't forget the lawsuits from community groups, the jurisdictional disputes between the Port Authority and the city, negotiations with multiple unions.
Nightmare. Each one is a potential veto point.
Exactly. The system creates what the source calls indefinite obstruction. It argues that in the U.S. and much of the West, Our system of checks and balances has become so complex that it has metastasized into paralysis when it comes to large-scale physical infrastructure.
So while we're holding a decade of town hall meetings to debate the aesthetic impact of a single charging station,
Lao Chen is watching the future get swapped into a 10,000-ton vessel in 5 minutes. That's the practical difference. The paralysis of vetocracy makes the rapid systemic deployment of something like the crane and block system almost impossible. You can't have a synchronized nationwide battery network if every single county can veto the location of its swap station.
the logistics performance index then isn't just about having the best technology.
It's about having the political and social capacity to deploy that technology at scale and at speed. The system that Lao Chen is seeing is a physical manifestation of a state that has retained the ability to act decisively in the physical world.
This idea of capacity, of being able to act, it's not just about the government, is it? It's about the people on the ground, the ones actually building this stuff. And that leads perfectly into our second story, which for me was one of the most powerful things I read. It's the perspective of a young structural engineer working at a shipyard in Jiangsu province.
Right, the hard-tech view from the front lines.
Exactly. So this engineer, he posts online about his work. He's not writing code for a social media app. He's not optimizing ad-click algorithms. His job is to oversee the lowering of permanent magnet motors, which are the size of a small house, into the hulls of these new electric ships.
And we should pause on that for a second. A permanent magnet motor is not just a bigger version of a regular motor. This is advanced material science. These motors rely on rare earth elements like neodymium and dysprosium for their magnets. These elements allow you to create an incredibly powerful and efficient motor that's much smaller and lighter than a traditional induction motor. And not coincidentally, the processing and supply chain for those specific elements are heavily concentrated in that part of the world.
So he's lowering this high-tech, strategically important piece of machinery into the hull of a ship. And he writes about his cousin. His cousin got a Western education, works in finance, probably in Shanghai or Hong Kong. And his job is to move what the engineer calls imaginary numbers across imaginary borders.
The tangible versus the abstract.
It's everything. The engineer writes, while he trades derivatives, I am forging physical sovereignty. He uses this term, hard-tech hegemony. For him, true national strength isn't a soaring stock index or a complex financial instrument. It's the real tangible ability to transform raw materials, silicon, lithium, steel, into a logistical reality that works.
You know, it's easy to hear that and dismiss it as, just nationalistic pride or propaganda. But if you actually dig into the economic papers we have, especially the Rand report on measuring national power and the Zoo paper on strategic trade, his statement is grounded in serious economic theory.
So, because from where I'm sitting, my retirement account would argue that finance is pretty powerful.
Finance is incredibly powerful when the underlying physical system is stable and functioning. But the Rand report asks a different question. Where does real power come from in a post-industrial age? And especially, where does it come from in a crisis?
Okay.
And their conclusion is that durable power comes from two things: differential rates of capital accumulation and manufacturing proficiency. In simple terms, it means the nation that can build complex, essential systems faster and better than its rivals is the one that has hegemony.
So it's not about who has the most money in the bank at any given moment.
Not if that money can't buy you the things you need because the supply chains are broken or the factories are somewhere else. In a major global crisis, you cannot eat a derivative. You cannot use a hedge fund to transport grain.
Right.
The sources we have identify shipbuilding and battery technology as the new leading sectors. These are the industries that are like the railroads or the semiconductor fabs of their time. They generate what economists call supernormal profits, and more importantly, technological spillovers.
Spillovers meaning if you get really good at making high-density batteries for ships, you also get really good at making them for grid storage. Or for electric cars.
Or for military application.
Or for autonomous.
Or for autonomous drones. Exactly. It
Right.
creates a whole cluster of innovation and capability around it. An economy that is primarily focused on finance misses out on those crucial spillovers. And then the Zoo paper brings up this critical concept of learning by doing.
This is the simple but profound idea that the only way to get better at building things is to actually build things.
It sounds obvious, but it's something many Western economies have forgotten. This is the danger of decades of outsourcing. When you send your manufacturing overseas, you don't just lose the factory jobs. You lose the skills. You lose the institutional memory.
The muscle memory of industry.
Yes. The Jiangsu engineer every single day is solving hundreds of tiny, complex problems in welding, in thermal management, in motor alignment, in software integration. He and his team are getting infinitesimally better, smarter, and faster every day. His cousin in finance is learning how to structure a new financial product, not how to weld titanium or program a battery management system.
And that gets to his idea of physical sovereignty.
The Zoo paper cites the economist Oren Cass on this, the idea of a nation needing the ability to make goods for goods. Ultimately, an economy is about trading physical things for other physical things. Money is just the lubricant. If the global financial system, with all its derivatives and currency markets, were to seize up or collapse,
The country with the ships, the batteries, and the factories to make more of them keeps functioning.
it keeps functioning. The country with the complex derivatives, contracts, does not.
That is a very sobering thought. It feels like we've spent decades optimizing our economies for transactional efficiency, while they've been optimizing for physical resilience.
For resilience and for control of the physical layer of the global economy. The engineer in Jiangsu, he understands that he is building the foundation of the house. His cousin is just rearranging the furniture.
This theme of control, of resilience, brings us directly to the geopolitical angle. This isn't just about economic theory, it's about hard-nosed national security. And our third story illustrates this perfectly. It comes from a coastal captain, a guy who spent his whole life on diesel tankers and just recently made the switch to commanding one of these new electric vessels.
And the story, I think, really gets into the psychology of energy security.
He talks about this feeling he has now, which he calls the silence of autonomy. He says for his whole career, he used to dread his morning routine of checking the news.
Because of the oil markets.
Every time there was a political crisis in the Middle East, a pipeline explosion in Russia, a new round of sanctions being threatened somewhere, he knew instantly that the price of diesel, his ship's lifeblood, was going to spike. He said he felt like a prisoner to global chaos.
Which is a good description of the fossil fuel market. It's a system defined by entropy and volatility. It's inherently unstable.
Exactly. But now, he says his whole mindset has changed. He feels like he's operating behind what he calls a battery shield. He pulls into port and plugs into a grid that's powered by domestic resources, domestic coal, domestic solar, domestic wind. He feels insulated from that global chaos.
And that personal feeling of insulation he has connects directly to a major national strategy. The strategic trade source we looked at talks about the concept of dual circulation.
Dual circulation, it sounds a little like a medical term.
It's a core strategic concept for them. Think of it as two loops. One loop is the global economy, international trade, which they are still very much a part of. But the second loop, the domestic one, is designed to be increasingly self-sufficient and resilient.
And oil is the big vulnerability there.
China's reliance on imported oil creates what strategists have called the Malacca dilemma for decades.
Right, that's the Strait of Malacca, the narrow shipping lane where a huge percentage of the world's oil tankers have to pass through.
A massive portion of China's imported oil comes through that one narrow strait between Malaysia and Indonesia. In any potential conflict, it's an obvious choke point that could be blockaded, cutting off their energy supply.
So by electrifying their internal shipping routes, the huge Yangtze River, all the coastal traffic, they sidestep that dilemma.
They completely remove that vulnerability for their domestic economy. They no longer need imported Middle Eastern oil to move goods from Shanghai to Chongqing.
They can power their entire internal logistics network with domestic electrons. And it doesn't even matter if those electrons come from coal or from solar panels.
As long as they are domestically sourced, it creates a closed-loop system. It's a strategic move to build resistance to that global entropy we talked about.
So the diesel endgame really isn't about clean air. That's just a convenient side benefit.
It's the marketing layer. The strategic core is about national security. It's about insulating your domestic supply chains from external shocks. It's about not having to care what the price of Brent crude is in London or what OPEC decides in Riyadh.
And you can't talk about this without mentioning the company at the center of it all, CATL. The source from Charged EVs magazine calls them the dominant global player, which feels like an understatement.
It is an understatement. They are the battery giant. But they're much more than that. The source makes a really insightful comparison. It compares CATL to Standard Oil in the early 20th century.
Meaning they don't just sell the product.
They built the entire system. Standard Oil didn't just sell oil. It owned the wells, the pipelines, the refineries, the delivery network. CATL is doing the same thing for this new era. They're running what's called the Ship-Shore Cloud solution.
Ship-Shore Cloud.
They manufacture the batteries, they partner to build and operate the swapping stations on the shore, and they run the cloud-based software platform that manages the entire network, predicting energy needs, optimizing charging schedules, tracking battery health.
So they are the new Standard Oil, but for electrons.
And that level of vertical integration and centralization allows for a degree of strategic coordination and capital deployment that a fragmented, market-driven system just cannot hope to match. They can move with a speed and scale that effectively dictates the standards for the rest of the world.
It's incredible how all these pieces fit together. The ships, the batteries, the economic theory, the geopolitical strategy. But, it's not just the boat itself, is it? It's where the boat docks is. We touched on the crane, but the whole smart port ecosystem that's being built around these vessels is, well, it's just as revolutionary.
Yes, the Jinhua Baltic report has a ton of data on this. We're not just talking about a smarter crane. We are talking about the creation of digital twins.
Digital twins.
Imagine a complete real-time virtual replica of the entire physical port existing in the cloud. Every crane, every truck, every container, and every ship.
So the ship and the port are in constant communication long before the ship actually arrives.
The port's AI has a digital twin of the incoming vessel. It knows exactly which battery blocks are depleted. It knows their exact location in the ship's hull. It knows which containers need to be unloaded and where they need to go. And it choreographs this entire ballet of AI-driven cranes and autonomous self-driving trucks to be in perfect position the second the ship ties up.
So it's not just a swap, it's a pre-calculated robotic ballet.
A robotic ballet. The report mentions the port of Tianjin collaborating with Huawei to use 5G in their AI platforms to run the whole thing. Ningbo Zishan, which we mentioned, is already handling over 35 million container units a year with these kinds of smart terminals.
And the 5G is critical, right? Because of the low latency.
Critical. You cannot have a remote operator controlling a 100-ton crane if there's a half-second lag in the connection. It has to be instantaneous and totally reliable. This is an industrial application, not just faster movie downloads.
And Tuas Port in Singapore, which is functionally part of this advanced Asian logistics ecosystem, is taking it even further. Fully automated, using drones for inspections, a whole fleet of electric vehicles. The source calls it a logistics fortress.
And then when we turn the lens around and compare this integrated vision to what's happening in the West.
It's a painful comparison. That CSIS source we have is brutally honest about it. It talks about the struggling shipbuilding industry in the United States. We effectively don't build large commercial vessels for international trade anymore. Our battery manufacturing sector is playing catch up.
The fundamental disconnect seems to be where we choose to innovate. The West excels at digital abstractions. We build the world's best software, the most engaging apps. We're conceptualizing the metaverse.
But the East is applying its digital prowess to physical hardware. They aren't building a metaverse to escape from physical reality. They're building a digital twin to master physical reality.
That is a crucial difference. They are using code to move steel with unprecedented efficiency.
Yeah.
We are, arguably, using code to move attention.
When you put it like that, it feels like we've uncovered two completely different philosophies about what the future is even for. It's not just about who has better technology, it's about what you apply that technology to. Is it for the movement of things, the powering of things, the building of things, or something else?
It's a fundamental divergence.
Yes, we've really looked at this from three different levels. We have the story of Lao Chen, the crane operator. He represents the system, the view from the ground, seeing the sheer scale and top-down standardization that makes the individual feel small, but also part of something massive and secure.
Then you have the second story, the engineer in Jiangsu. He's the voice of the industry. That pride in hard tech, in physical sovereignty, and the explicit belief that building tangible things is superior to pushing financial paper.
And finally, we have the coastal captain. He represents autonomy, that feeling of being shielded from the chaos of global oil markets, the freedom that comes from energy independence on a personal and national level.
And the thread that ties all three of those stories together is this core thesis we keep coming back to. We may be witnessing a historic shift from an era of financial hegemony, where power is defined by who controls the money, to an era of hard tech hegemony, where power is defined by who have the physical capacity to build and move things.
But I think we in the West, we tend to imagine the future as being invisible, data floating in the cloud, AI humming away on a server farm somewhere in a desert. We think lightweight. We think the future is supposed to be immaterial, like air.
We We often confuse advanced with dematerialized. We have this bias that if you can't touch it, it must be more sophisticated.
But then you look at that silent 10,000-ton ship gliding into port. You look at those 4-ton battery blocks being swapped by a robotic crane, and you realize the future might not be lightweight at all. The future looks incredibly heavy. It looks like steel. It looks undeniably physical.
That right there is the heart of it. The diesel endgame isn't just about engines. It implies that the civilization which masters the thermodynamics of movement, the one that can move mountains of cargo across continents using silent swappable electrons, is the one that secures the right to navigate the 21st century.
It really does just boil down to physics in the end. You can argue about politics, you can debate different economic models all day long, but you can't really argue with thermodynamics.
And so the question for all of us isn't whether you like the system that built this silent ship. The question is, can you compete with the physics of it?